So dear participants, welcome back with our discussion on programmable logic controllers. Now you see that one of the greatest advantages that the PLCs do enjoy is that you can use the same controller with a wide range of control systems, just like a microcontroller. You can apply the same microcontroller for various control operations. The PLCs do afford to have that advantage also. So you can use the same controller. Okay, you need to change very basic wiring requirements if it is at all required. So in order to modify a control system and the rules that are to be used, all that is necessary is to design a different set of instructions. There is no need to rewire. Although I have said there is no need to rewire, if the situation demands like that, you have installed a particular sensor for certain operation, now you have to work with a different one, then there may be rewiring necessity. But if we consider with relay systems, such necessity will be minimized to a factor of 99.9%. So if suppose you are applying a PLC for a particular application at this point of time, and within 10 minutes you have got a change in the situation, and now you have to define a different logic, what you need to do is very simple. You need to stop the operation of the PLC, or you can keep the PLC operating in its present process right now. You can make a different program. You have to stop the PLC for a moment. You can load this newly defined program onto the PLC and apply the PLC to work with the revised version of the program. So therefore, you are only required to know the programming aspect of the PLC properly. You need to know the condition that has been arised due to some process operation that you need to automate, that you need to control through the PLC. Accordingly design the program, feed the program, you are ready. So every time there is no headache for rewiring the system. Earlier, which we have seen that it was the condition for a relay operated system. Therefore, with the installation of PLCs in our system, we acquire a very flexible system which is also very cost effective, so that we can address various nature of the work and various complexities of the work that may be there from the process demand. Now we are trying to compare the PLCs with relay system. So the first thing is that in case of PLCs, we can easily implement changes, and changes are implemented in software. Earlier, when we were having a relay system, what we had to do, we had to carry out very complex hardware modifications. Hardware modifications means we have to remove some wires, we have to rewire some wires in some different conditions, which is not now the case when we are using PLCs. We can easily expand a PLC system. We can easily expand a PLC system. Nevertheless, the requirement is a modular type of PLC. Suppose you are having a certain process right now. Now after a few years or few months, there are new demands from the process. Your process has got a bit amplified. Earlier there were only 3 valves to be controlled. Now you have 12 valves to be controlled. So if such is the situation, then you may have to change a lot of hardware changes if you are using a conventional relay system. But for a PLC, you can just add up more DIDO units, or if you are using a PLC which were having some DIDO units left vacant, you can definitely add them for your purpose right now. So such things are there. if the system has to be enhanced, if the system has to be enlarged, if the system has to be advanced, then the PLCs can help you a lot. Here you need not to bother about tremendous amount of hardware changes which were earlier with relay based units. Now PLCs are more robust and reliable than relay systems, because in relay systems you have large number of mechanical components. Continuous operation of the mechanical components, they cause wear and tear within the relay units. They get heated and they might fail in long run of operation. The PLCs are more compact than relay system. So if you have a very gigantic relay system, you can have a very big control panel with large number of wires, and whenever there is certain problem that you have to troubleshoot, it is a very tedious job with a relay system. Now PLCs require less maintenance and definitely they can operate faster than the relay systems. Now let us look into PLC hardware. Let us now consider more profoundly onto the PLCs itself. Now whatever you can see is the block diagram of a PLC system. You can find that this block diagram, at the central it is having actually a processor. Then there is necessity of a power supply. That power supply gives power to all units of the system, which includes the processor. There is an input interface and there is an output interface. To the input interface is connected the input devices, and to the output interface are connected the output devices. Then there is a program and data memory section which can talk bidirectionally to the processor, in which we are actually putting our program, and there is a communications interface so that the PLC can communicate with the external world. Now why it is important that it will communicate with the external world? Because PLCs very seldom they work as stand-alone units. They have to communicate with large number of other PLCs, or they have to communicate with an human machine interface. They have to communicate with remote IO stations. Maybe they have to communicate with a robot. They have to communicate with a VFD. They have to communicate with a very massive SCADA station. So all these things are there, which are there in the factory network. There are so many things in a factory network. So whenever such demands are there, your PLC cannot work as a standalone unit. It has to communicate with other parts of the factory also, other machines of the factory also. Under such circumstances, this communication interface is very much required. Now you are able to see that all the units, this program and data memory unit, the communications interface, the input and output interface, they are having bidirectional relation with the processor. Because the processor is the central unit and every unit needs the help of the processor, or they need to feed some data or input to the processor so that the processor can decide which logic has to be performed and how it has to be performed. Now the power supply is connected to the mains power unit. There are many PLCs which do not contain an inbuilt power supply, and you have to connect specially designed power supply to the PLC, which can give very stable DC input, DC supply to the PLC. Because if the power supply is not of a good quality, then the PLC might get damaged, because that much care you have to take while working with a PLC. Now you see that this PLC actually they contain a vast number of separate relays, counters, timers and data storage units inside the PLC. However, you can be very assured that that does not enlarge the size of the PLC, because they are all software simulated inside the PLC itself. And many a times, let me tell you that it is not that much required to know what is actually happening inside the PLC. The PLC is very much self-contained unit. There are many operators of PLC who are perfect in programming languages, who are developing tremendous systems for the system integrators. You ask them what is happening there inside the PLC, they actually do not know. But what they know is how it is operating, and that is actually required in many cases in the industries. because we need not to see what the processor is actually doing, what the communication interface is actually doing. You must know that which communication interface is there and how I can operate with that communication interface. Many times it happens that you know that it is an RS-232, but you do not know how to operate with that RS-232. Then what is the goodness of learning that? You need to know that how it can operate with that, how you can communicate with the PLC. देखिए, मशीन के साथ बात करना इतना आसान नहीं है. जैसे कोई नए परिचित इंसान है, उसके साथ बात करना बहुत आसान नहीं रहता. उसको समझना पड़ता है, सोचना पड़ता है, उसके बाद धीरे धीरे उसके साथ अपनी मैत्री बढ़ानी पड़ती है, तब जाके आप खुल के बात कर सकेंगे. मशीन भी वैसा होता है, एकदम बच्चों की तरह होता है. वो बहुत कैपेसिटी रहता है उसमें, बट आप उसके साथ सही मायनों में पेश नहीं आएंगे ना, वो आपको कभी भी जवाब बरोबर नहीं देगा. You love the machine, it will love you. It is very important to understand here. Now you see, we will go for bit by bit discussion. First of all, there is a central processing unit. It contains the microprocessor, which is the heart of the PLC. This unit interprets the input signals and carried out the control actions according to the program stored in its memory. Now you see, you actually store the program in the memory. Then the PLC actually decodes the program and it makes the program understandable by the microprocessor, and accordingly the microprocessor takes the decision through the logic units, the arithmetic units that are already there in the microprocessor, and finally it communicates the decisions as action signal to the output. ये बहुत इंपॉर्टेंट है. माइक्रोप्रोसेसर में सबसे पहला काम क्या है कि जो भी इनपुट आया उसको देखना, फिर प्रोग्राम को देखना क्या है. प्रोग्राम समझने के लिए आप जिस भाषा में प्रोग्राम लिख के देंगे वो माइक्रोप्रोसेसर समझेगा, ऐसा बिल्कुल नहीं है. देयर इज पर्टिकुलर डिकोडर, वो प्रोग्राम को कंपाइल करता है, फिर डिकोड करता है. जैसे अपने माइक्रोप्रोसेसर और कंट्रोलर में होता है, सेम चीज यहीं पे भी होता है. बट ये सब चीजें आपको जानने की जरूरत नहीं पड़ती, बिकॉज पीएलसी इज इटसेल्फ हैंडलिंग दैट. तो माइक्रोप्रोसेसर क्या करेगा, जो भी आपने प्रोग्राम किया उसके हिसाब से वो देखेगा इनपुट क्या है और उसके हिसाब से आउटपुट क्या होगा ये डिसाइड करेगा. अब आउटपुट डिसाइड करने के बाद इट विल कम्युनिकेट द डिसीजंस एज सिग्नल्स टू द आउटपुट. अब ये सिग्नल क्या है, आइदर आउटपुट को हाई करेगा या लो करेगा, या अगर एनालॉग है तो उसमें करंट धीरे धीरे बढ़ाएगा, स्लो बढ़ाएगा, कितना बढ़ाएगा, ये सारी चीजें डिसाइड करेगा. एंड अकॉर्डिंगली वो आउटपुट में ये सिग्नल भेजेगा सो दैट योर आउटपुट कैन बी अपडेटेड according to the program that you have fed to the PLC and according to the situation of the internal switches or sensors. Now there is the power supply unit. अब power supply unit बोलने की कोई ज़रूरत ही नहीं है. It converts the main AC voltage to the low DC voltage that is necessary for the processor and other circuits that are inside the PLC. Now you see that many of the PLCs, they require external power converters. Okay, and such power converters should be able to supply 24 volt DC, which is a typical value. The 24 volt DC is the typical value. Then there are internal converters that further condition the voltage to suitable level for processor operation. Now, because the processor, that is a digital device that will work at level with no more than 5 volt. 0 volt is the minimum and 5 volt is the maximum that will be needed by the processor for all its operation. However, whenever we are applying the PLC for controlling the inputs, for sensing the inputs and controlling the outputs, then 24 volt DC is a globally accepted norm. If it is DC, it should be 24 volt DC is a globally accepted norm. So that you have to apply. Now you see that this thing is not a Bible. 24 volt DC is not the final word that has been spoken with the PLC. If it has been required by the PLC that 240 volt has to be applied, you need to apply 240 volt. If it is required, you go to US. There is 120 volt is the norm, 110 or 120 volt AC is the norm that you have to supply to the PLC if it is required like that. So whenever you are using a PLC, you are purchasing a PLC, you are programming a PLC, you are applying a PLC for certain operations, kindly go through the manual, go through the information brochure and go through the product number of the PLC, the product code of the PLC. That product code will actually let you know what are the power requirements, what is the maximum voltage that you can give at the input, what is the maximum current that you can draw from the output. So all these things are there. That you need to know very clearly. So please do not rely on the lectures that I am sharing with you. You kindly go through the websites, you kindly ask for some brochures of PLCs, you kindly ask for the technical documentation of the PLCs from the website. Otherwise, I am very sorry to say there is no goodness of studying this PLC as a paper. I will be also supplying some of the materials to you. Next, there is a programming device. It is required. This programming device is required to enter the required program into the memory of the processor. The program is developed in the device first, and then it is transferred to the memory unit of the PLC. Such a programming device can be a handheld programming device, a desktop console, or a computer. Now you see, suppose you are in an industry, okay, where the PLC is already installed in a very remote location and which is a very hard to reach location. Normally PLCs are not installed in hard to reach locations, because if the locations are hard to reach, then if some troubleshooting has to be done, if some wiring change has to be done, you have to play a lot with the PLC because of its very clumsy position. So therefore the PLCs are normally located in proper normal accessible points. However, it is not always possible to carry out your laptop or your desktop to the PLC to program it. For that purposes, every manufacturer, they have developed their own handheld programming devices. Now that handheld programming devices that have got memory to allow the unit to retain the program when being carried from one place to another. So that carries the program and you can feed the program onto the PLC. You can have desktop consoles that do have visual display unit, full keyboard and screen display. So that is a just like a teach pendant that you are using for programming a robot. Such type of devices are there. You have to connect it to the PLC through the communication interface, and then you can change the program with the keyboard and the screen display, and that you can feed to the PLC. And finally, personal computers are very widely used for programming the PLCs. Now you may hardly find such desktop console or handheld programming devices across even Aurangabad or even many factories in Pune. They are actually the particular system integrators or the troubleshooters. They carry their laptops to the PLC, and there they program the PLC. They program in laptop and they feed to the PLC. You can connect the computer or your or whatever your laptop to the PLC with Ethernet. You can use RS-232, RS-485 or RS-422 cabling. So such type of all cablings are there. And remember that while do this cabling, it is very much required that you understand that whenever you are using certain protocol to join your PC to the PLC, you need to be very versed with it, because there are several steps that you need to remember. Because every time you want to put your PLC connected to your PC through an internet option, then you need to be very sure what is the MAC ID of the device, what is the Ethernet ID of the device. So and there are several other things. These port options are there. Then you need to know your this I should say the requirement of the network administrator might be there in order to know every detail, because if your PC is already connected to some network and now you want to connect your PLC to the PC, then there are several things that you need to know. During your practical sessions, you will come across all those details. You need to know the, as I have already told, you need to know the proper MAC ID of the device. You need to know the proper Ethernet ID of your PC, like that. So you need to be very sure about all these details. Otherwise, it will be very hard for you to get your PC communicated with your PLC. And although you are ready with the program, you will not be able to program your PLC because you are unable to connect your PLC with your PC. You need to be very sure about your server address, and like all those things are there. You will be coming across all those things in your practical sessions. I'm 100% sure. So you need to be very careful. On the very first day you are programming a PLC, maybe through Ethernet or through RS-232 or through RS-485. Keep a proper notebook to write down every detail, what are the various steps, because you may find that the person who is expert in this, he will be doing several steps in a very quick manner. It will be very hard for you to follow. So you need to note that things properly, and then you are able to communicate with your PLC, with your PC to the PLC, and then you are able to program the PLCs very easily. So we stop here and we will again continue with the next lecture.